Hello students, in our previous part we discussed about molarity and percentage concentration. So let's start. Now we are going to learn about the other ways of expressing the concentration of a solution. That is, one is molality. So don't confuse with molarity. So molarity is different from molality. So this is L and it is denoted by small m. Small m represents the molality of the solution. So molality is defined as the number of moles of solute dissolved in 1 kg of the solvent. The number of moles of the solute dissolved in 1 kg of the solvent. So that the expression for molality is the number of moles of solute, that is N, divided by the mass of solvent in kg. Okay. So here careful about it. It is not mass of solution, it is the mass of solvent only. Okay. So it is the mass of solvent and you need to take it in kilograms. You can also take in grams. That in that way you need to multiply it with 1000. So number of moles N divided by the mass of solvent. Mass of solvent, if I represent mass of solvent by M solvent, if I take it in grams, then I need to multiply it with 1000 to get the molality of a solution. Okay. So number of moles represent what? The same story. It is mass of the solute divided by the molecular mass of the solute. Okay. So here two things you need to require, and that is, one is the mass of the solute, other is the mass of the solvent. Okay. If you know these two things, you can easily calculate molality. Okay. And molecular mass you already know, you can calculate easily. So if you know these two things, you can calculate the molality value. Okay. And the molality is expressed in what? It is expressed in mole per kg. Mole per kg is the unit for molality, and 1 molal, this is molal, 1 molal solution contains 1 mole of the solute in 1 kg of the solvent, right? So if I take 1 kg of the solvent, if I take 1 kg of water, that is 1 liter of water if I take, and if I add 1 mole of the solute to that, I will get 1 molal solution. Okay. 1 molal solution can be prepared by adding 1 mole of the solute to 1 kg of the solvent, that is 1000 grams of the solvent. And if you see, molality is temperature independent. It is temperature independent, unlike molarity, which depends on temperature. Here the molality is temperature independent because here it does not contain any volume term. It is number of moles. Number of moles is not going to be varied by temperature. Even if you increase or decrease, number of moles remains same all the time, and mass of the solvent is also not going to be changed by temperature change. Okay. So nothing depends on temperature. So molality is independent of temperature. Okay. So molarity depends on temperature but not molality. Next is mole fraction. Mole fraction is another way of expressing the concentration of a solution. That is mole fraction. Okay. So let's take a solution. The solution contains only two components. One is A and other is B. A is one component and B is other component. So since it is containing only two components, we can call it as a binary solution. Okay. So this is a binary solution. I want to calculate its mole fraction. Okay. So how I can define mole fraction of a particular component? So say suppose this solution has number of moles of A is Na and number of moles of component B is Nb. These are the number of moles which I can calculate by knowing the mass of A and B, right? So the mole fraction of A is defined as the number of moles of A divided by the total number of moles. That is, so mole fraction represented by the x, and this XA, this is the mole fraction of A, which is equal to the number of moles of A divided by the sum of moles of all the components. Here A and B, both we have only two components. So the mole fraction of A is simply, it is the number of moles of A divided by the total number of moles, that is Na plus Nb. Okay. Similarly, you can calculate the mole fraction for B, that is the number of moles of B divided by the total number of moles. in the solution. Okay, so the NB by Na plus NB represents the mole fraction of B. Mole fraction of B, right? Yeah, which I already discussed. So if you add these two, what you will get? If I add this mole fraction of A and mole fraction of B, what I'll get? I'll get 1, right? I'll get 1 because the solution contains only A and B, only two components we have. So the sum of mole fraction of both the components, they add up to 1. Okay, so for a binary solution, we have mole fraction of A plus mole fraction of B is equals to 1, and it is not only applicable for binary solution, even if the solution contain n components, so this relation still valid, that is mole fraction of 1 plus mole fraction of 2 plus mole fraction of 3, and say suppose the solution contain n components, so the sum of all these mole fractions will still 1. Okay, so this is about mole fraction, and the mole fraction is, if you see, it is not non-dimensional because it is a ratio of two similar quantities, and it is also temperature independent, right? Because there is no volume term here. Since there is no volume term, it is surely the temperature independent one. So we have two temperature independent one, that is mole fraction is one thing and molality is other thing. These are temperature independent, whereas molarity and normality, these two are temperature dependent. Okay, so let's solve a problem based upon whatever the concept that we discussed till now, that is about the ways of expressing the concentration. Yeah, this is first problem. In our glass of iced tea, we have added 3 tablespoons of sugar, that is C12H22O11. The volume of the tea, that is water, is 325 ml. What is the mole fraction of the sugar in the tea solution? First of all, write down the data. Okay, so first of all, let's write down what is given in the question. So we have here, what is the solute? The solute is sugar, right? So first of all, identify the solute and solvent. So sugar is the solute, that is C12H22O11. Its molecular formula, they already given, so no need to worry about it. So it has 3 tablespoons we added, and the volume of the water, that is the solvent, is 325 ml, right? So the volume is given as 325 ml, volume of the solvent. So what is the mole fraction of the sugar in the tea solution that we want to calculate? That is the mole fraction of solute I want, that is sugar I want. Okay, so how can you calculate the mole fraction of sugar? You can calculate if you know the number of moles of sugar divided by the total number of moles in the solution. So how you can calculate the number of moles of sugar and the number of moles, total number of moles? For that, you also know, you need to know the number of moles of water also, that is the solvent. If you know these two things, you can calculate the mole fraction of sugar. So think about it, how we can calculate both the things. Here one information is given that 1 tablespoon of sugar is approximately 25 grams. So we added 3 tablespoons, that is 75 grams of solute we added. So number of moles of solute we can calculate, right? That is 75 divided by what is the molecular weight of sugar? If you calculate, it comes around 342. So the number of moles of sugar we got, that is equals to 0.219 you will get. 0.219 is the number of moles of sugar. So 1 we already done. So let's think about how we can calculate the number of moles of water, right? So the number of moles of water, for that we need to know the mass of water, because we already know its molecular weight. So mass of water we want to calculate. It is volume of water given, that is 325 ml, right? So since the density of water is 1 gram per ml, so mass will be simply the density into volume. So that is 1 into 325. The mass of water is how much? 325 grams of water we have. Okay, So we can calculate its number of moles, right? So the number of moles of water is equals to, the mass is 325 divided by the molecular mass is 18. So this is 18.1 you will get. This is the number of moles of water. So we got both. So the question is done. The mole fraction of sugar is equals to 0.219. That is its number of moles divided by the total number of moles. 0.219 plus 18.1, which comes out to be 0.012. This is the mole fraction of sugar in the solution. Okay. So this is what asked to calculate, but you can also calculate the mole fraction of water also. That is simply 1 minus of this one, right? Because the mole fraction of both the things, the sum of the mole fraction of both solute and solvent is equals to 1. So for solute it is this one, for solvent it is 1 minus 0.012. This gives the mole fraction of the solvent, that is water. Okay. So this is how you can solve the problem. You can solve the problem. First of all, write down the data, and from the data look for the quantities that you need to require to calculate whatever asked in the question, and let's see, analyze the data and look for the formulas to calculate the required things. Okay. So this is the first problem, and let's solve one more problem based on this, that is illustrative problem 2. So here we have 12.6 grams of NaCl is dissolved in water, making 344 ml of solution. So calculate the molar concentration. Molar concentration is nothing but its molarity. Okay. So molarity you need to calculate, and mass of NaCl is given, that is equals to 12.6 grams, and what more is given? The volume of the solution is given. The volume of the solution is 344 ml. So write down the formula for molarity. So molarity is equals to number of moles of solute divided by the volume in ml into 1000, right? If you recollect. So number of moles is nothing but its mass by its molecular mass, that is 12.6 grams divided by NaCl is how much? It is 23 plus 35.5, it is 58.5. So 58.5, this is number of moles into 1000 divided by the volume is 344 ml. Yeah, if you calculate this one, we can get the molarity easily. That is around 0.627 will get. So here nothing twist is there in the question. Everything is given. The mass is given, the volume is given. So if you know these two things, just it's all about the calculation, right? Calculation you need to do correct in order to get the correct answer. Okay. While studying this chapter, if you get any doubts, you can post it for free on askIITians.com. How? First, open the website, and if you see at the top right, you will see a discussion board. So simply click on that. It will take you to the next screen. Yeah. In the next screen, you will see the Ask Experts, a separate section on the right hand side. So select a relevant category for your question and simply post your question here. We experts at askIITians will provide answers to your questions within 24 to 48 hours. Stay tuned on askIITians.com for my more upcoming videos, and also the videos related to other subjects like maths, physics, chemistry and biology. For any more queries, you can post it on askIITians.com. Hopefully you enjoyed with this session. Thank you.